Right, let's look through what you did in the last lesson. Um, Responses. Here we go. Ah, there we go. Right. Well, there was only one real question. It says, which is the best definition of a species? And 20 of you got it right. It is. It's they can breed to produce fertile offspring. And 8 of you have put they have specific features unique to it and its relatives. That's like saying, birds have got feathers. Well, that's unique to that to to that, but there's lots of different kinds of birds. So you need to be careful with that. Sometimes it works for a species, but sometimes it doesn't. Things can look very, very similar, but because they can't breed together, they're not classed as separate species. And sometimes they can look really different. If you think about the dogs, like a Chihuahua and a Great Dane, technically they can breed to produce fertile offspring. So they are the same species. Hence, we call them breeds of dog, not species of dog. Um, I was pleased with the animals. I mean, just to go through, 2 of you went for fish, 4 of you went for amphibians, 3 of you went for reptiles, an amazing 17 mammals and no birds. So over the vertebrates, the mammals were the most picked. I think the most picked animal was the red panda and the giraffe, as in 2 people went for each of those. 2 people went for invertebrates, so I got 2 mollusks as well, and so I look forward to reading about them. Mollusks are things like squid and octopuses and cuttlefish, things like that. They have um, they tend to have shells or an internal shell. So let's have a look at your facts. Print them off here. So Claudia went for the desert rain frog. When the desert rain frog is annoyed or threatened, it makes a squeal that sounds like a dog toy. Fantastic. Harley, group of cats is called a clouder. Male is a Tom, I know that. Female is a Molly or a Queen. Yeah, we've been associated with cats for 10,000 years. Wow. Is it not like a pride of cats? Who knows? Um, Mohammed, the adult male roar can be heard 8 kilometres away. Amazing. Danielle, can I have a shout out as I've tried very hard at my work and I chose a unique animal? You did. You picked a cephalopod, a mollusk, the Dumbo octopi. Technically octopus, but I shot like a mark out for that. The scariest was the gharial, big toothy kind of crocodile type thing. I didn't realise it was so long. Yeah, I didn't. Zena found out that male platypus can produce venom. They can. A baby platypus is called a puggle. Oh, fantastic. And they have a sense due to their bills and they don't have a stomach. How do they digest food then? I'll have to find out about that. Amalie, I found out that the temperature of the turtle nest decides the gender of the turtles. It does, yes. Yeah. At a certain temperature, they're all male, and females, and therefore, if you're higher up on like a warm day, you're more likely to be male in the nest. Daniel's one of those who did the red panda. Adaptations start with enlarged wrist bones located in the front paws. It actually serves as a thumb and allows pandas to grasp and hold bamboo tightly. Who knew? Guy wrote about induced ovulation and done some good adaptations on the cheetah. Yeah, human females release an egg like once every 28 days, whereas cheetahs and rabbits, as soon as they have sex, that causes the egg to be released from the ovary. Yeah, so it's an induced ovulator. So maybe we should say, instead of breeding like rabbits, you could say breeding like cheetahs. Good old thorny devil, a good reptile, has a false head and can drink through its skin. Amazing. Frogs, only 1 in 100 frogs born grow into a fully grown frog. Yeah, they don't do parental care. They just lay the eggs, leave them, so most of them get eaten. Another red panda fact: 20,000 bamboo leaves in a day. Wow, seriously? Wow, they must eat all day. Sperm whales can increase their heart rate on demand. Oliver, I wonder why that is. I guess, well, when they surface, they'll want to get oxygen around their body quickly, so they'll probably speed their heart up when they're at the surface, breathing air, and then they'll slow the heart down when they're diving. Yeah, that makes sense. Emily, Arctic is the only canid whose foot pads are covered in fur. Yeah, it's a canine. Yeah, and yeah, to grip on ice, it's got, and to insulate it, it's got fur on the bottom of its feet. Tabby, there are 13 different types of otter. Right, I wonder how many there are in the UK. I think it's just one species in the UK. I'll have to have a look. Dakota tadpoles are born blind, and only half of the cubs survive. Yeah, again, it's a horrible world out there if you're a wild animal. It's very easy not to make it. Survival of the fittest. And Joe's tigers have been listed as endangered on the IUCN Red List since 1986. Yeah, again, they're hunted, they're losing their habitat, they're under a lot of stress. Right, so what are you going to do today? Hopefully you've watched me explain everything on variables, and then this is your task. You're going to measure variation of these. These are pumpkin seeds. I've lined them up on graph paper. This is 1 millimeter graph paper, okay? And there's a bit of a shadow. So I've lined up the bottoms on this black line, so you don't need to worry about measuring this side. You need to measure where it gets to at the top. And you're going to measure that to the nearest 0.5 millimeter, okay? So this seed one that's 10 millimeters. This line here, 11, 12, 13, 14, 15 millimeters, and you're going to record that in a table. So I would, go back to this after, pause the video. Ideally, if it's on a phone, you can pinch and zoom, and therefore you can, have a measure. We're going to measure the length of pumpkin seeds. I've already measured their seeds. So in your books, this is remote classwork, today's date, and we're measuring variation in a population. I've already measured their masses. Very cleverly got my own scales at home. I'm a true scientist. You need to work out the mean and the mean, and you're going to record the length of seed here, again, to the nearest 0.5 millimeter. Okay, so just going back, you can see, I think, seed number 5, that one's between there and there. That's one I'd record to 0.5 millimeter, where that one's touching the line. So yeah, do your best. Again, if we're in class, we'd be doing this with actual seeds, but we'll have to do it with a photo instead. Improvisation. You're then going to plot a scatter graph. Okay, it was one that I didn't go through before. This is where we've got I've got a dependent variable on the x-axis, and I've got a dependent variable on the y-axis. I'm measuring the length of seed, and I'm measuring the mass of seed. Okay, and you have to draw this into your book, because you won't have graph paper, but I've just done 2 centimeters between each half of seed length. Again, you can pause it and copy it, and then I'm just using the lines on my page for the mass of seed in grams. Okay, and then you're going to plot the data onto there, and so you plot the points, but I also want you to plot the mean. Okay, so again, this isn't actual data, but if the mean seed length was 13.4, I'm going to put a line up there, and if the mean mass of seed was 17.5, this point here, that's the mean point. That's where our line of best fit is going to go through that point. Okay, so I'm going to put a special kind of mean point here, and that's where my line of best fit will go through that point. That's the only point it needs to go through. Okay, so I can again, these are my pretend points I've plotted. Then there's my line of best fit. See, it's going through the mean, and that helps me kind of then balance the points either side of the line. So that's what you're going to do in your books with the measured data from the seed. So we're looking at the variation in one species, and all these seeds, let's go back to them quickly. These are the offspring of a plant. It's like a little baby. If I plant that, it'd grow into a pumpkin plant. Yeah, so these are individuals. It's just they're in their nice and simple form. So hopefully that makes sense. Again, if it doesn't make sense, play it back, and it will hopefully make sense the second time. So your tasks, again, you can pause this. So you're going to copy the table into your book using the same title on that slide. You're going to measure the length of each seed to a resolution of 0.5 millimeters and record it in your table. You're going to make a simple graph as shown and plot the seed data. You're going to calculate the means and plot this special point. Then draw a line to show the correlation. The line must go through the mean special point, and the other point should be balanced either side of the line. The other task is that there'll be a form to fill in, so I know who's engaging with the learning, and I'm going to collect some data from you about your hand span and wrist circumference. When you do your hand span, just spread your hand out, put a dot either side of your fingers on paper, and measure between those dots. When you do the wrist circumference, it's basically just get a piece of paper, take a little strip, wrap it around your wrist, and then you can just find that wrist circumference, or you might have a tape measure at home. Do your best, improvise. We're all trying to cope with not being in school. So hope you're all well, and again, it's hopefully we'll get back to school pretty soon after Easter. And that's it from me. So take care.